Good evening, EL 120 students. Again, this is the Hillbilly Professor here to be able to give you one of your weekly lectures. Let's look and break out our 2023 code books. Today, I believe we need to do us a deep dive into Chapter 3, Wiring Methods and Materials. Chapter 3 is a really good chapter when it comes to doing some explaining as far as the conductors for general use. Let's go ahead and just dive right into it. So we can see that the articles broke up. Of course, it's in the 300 series like we talked about before. Uh, the article, General Requirements for Wiring Methods and Materials, General Requirements for Wiring Methods and Materials for Systems over 1,000 volts AC, 1,500 volts DC nominal, Conductors for General Wiring, etc. And it goes on down through here. As you can see, it's got lots of different articles. Talks about different types of cable assemblies, get deep into the 314, which is the outlet, device pull, junction boxes, conduit bodies, fittings, and handhold enclosures. You'll use the 300 series or the chapter 3 a lot as an electrician because it's got a lot of information. Your 31016 is in there for your capacities. Yeah, so let's kind of do a little bit of a dive here. So right off the bat, I want you guys to turn to Article 301. Okay. And it's going to give you an idea that this article covers general requirements for wiring methods and materials for all wiring installations, otherwise, unless modified by other articles in Chapter 3. Okay, so it gives you a baseline. Hey, unless it tells you something else, this is how we want these things done. In Part B, integral parts of the equipment. The requirements of this article are not intended to apply to the conductors from an integral part of equipment, such as a motor, controllers, motor control centers, or factory assembled control equipment or utilized equipment. Basically, if it comes from a factory and somebody else built it and you're installing it, that their wiring doesn't fall under the NEC code. We're talking about the NEC code picks up from where you make a connection to the equipment, supplying power to it. Okay, and we can kind of let a little bit more of an enhanced content I have that you guys don't. This is actually the online 2023 NEC book. I find it's easier for me to be able to do the videos with this. The requirements of specific wiring can be found in Chapter 3, article governing that particular wiring method. But the overarching requirements for wire methods are covered in the first article of Chapter 3. Chapters 5 through 7 modify some of the requirements of the Article 300. Chapter 8 is not subject to the requirements of Article 300, except specifically where it's specifically referenced. Article 300 also covers wiring requirements within boxes, conduit bodies, and fittings. So what does that mean? So basically anything that the wiring methods inside of boxes, conduit bodies, and fittings, it is the governing where their requirements, okay, this is where you're going to go to be able to find how many wires you can put in a box legally and safely, how many wires you can put in a conduit body, which is an LB, something that you see outside. We'll go into further on into the course whenever you see these particular pieces of equipment. And fittings. It talks about different fittings and different fittings for uses and whatnot. And that would be different than all types of fittings. I want to point something out to you. Further on in this book, you're going to see some references. You're going to see a lot of stuff that gives you a metric reference. Okay? You're also going to see at the same time the trade size. So there is a direct correlation between the trade size and the metric designator. Okay? For example, a half-inch conduit, its metric designator is 16. In the United States, 9 times out of 10, unless we're dealing with some Canadians or some people that are from otherwhere, you're going to be talking about trade sizes. As you notice, trade sizes run from 3/8 half inch, 3/4, 1 inch, inch and a quarter, inch and a half, 2, 2.5, 3, 3.5, 4, 5, and 6. Okay, these are the standardized sizes of conduits, flex, fittings, everything. This is our trade standard. Now, mind you, these are metric designators, and the trade sizes are for identification purpose only. They're not the actual dimensions. A 2 inch trade size will actually be just a little bit bigger, okay, as far as the conduit if you're going into a box or into a fitting. Let's see what this says. And I like this enhanced content because it kind of helps me explain to you. Metric designators are used for traditional size threaded conduit. They do not change the physical dimensions or the traditional MPT threads of the conduit. Metric designators are simply another method of identifying the size of a circular raceway. Table 301C, which is the one that we just looked at, identifies a distinct metric designator for each circular raceway trade size. What does that mean? It's a lot of words. What we're talking about is just basically the conduit themselves. Okay, just like we kind of covered. Each metric designator size circular raceway is identical in dimension, including the manufacturing tolerances to its trade counterpart. Okay, this is going to give me a link right over here. Another, that's the same. Let's see, we'll expand this out just a little bit. This is actually how many, this is the table that you go to be able to determine how many, okay, wires that you can put in via volume. This will be further on as we get into the course, as you get into the training here. We'll explain what these things do and how you use them. In the end, the code is set up similar all the way through. Lots of tables, lots of tables. You utilize these tables to be able to find answers in for questions. We're going to go ahead to 300 part 2, the limitations. Voltage. Wiring methods specified in Chapter 3 shall be used for 1,000 volts AC, 15,000 volts DC nominal or less. Were not specifically limited elsewhere in the Chapter 3. They shall be permitted to be over 1,000 volts AC and where 1,000 volts AC or 1,500 volts DC nominally were specifically permitted in this code. Basically, Chapter 3 is going to be covering anything under 1,000 volts or less. Okay, that is what we're going to be considering are a medium or less than medium voltage when it comes to the trade, because we have lots of different voltage types going all the way up to transmission voltage, which is 144,000 volts, all the way down to 24 volts AC. Your doorbells, they could very well be wiring on 12 or 24 volts AC in your house. That's what we're going to be covering here. That's what the limitations are. Temperature, okay? Temperature limitation of conductors shall be in accordance with 314A3. Temperature is our nemesis. Whenever you run a current through a wire, the magnetic field that it creates, the movement of the conductors or the movement of the atoms itself as they go through will actually generate heat. That's why it is that we have limitations on how many wires we can put into a pipe. That's why we have a limitation on the insulation of the conductors themselves, because heat dissipation is a requirement. Otherwise, what happens if you get a lot of something in a small area and it starts heating? What you end up with is thermal breakdown. You end up with the jackets or the insulation on the conductors themselves breaking down, and you start having failures. That's where you get fires. That's where you cause damage to structures. Okay, so let's look at the conductors themselves. Okay, 300.3 talks about conductors. Single conductors specified in 310.4.1 shall only be permitted where installed as part of a recognized wiring method system or wiring method specified in Chapter 3. Now, there's an exception. Okay, I want you to always pay attention. These exceptions may trigger you to have to go look somewhere else in the code book. Individual conductors shall be permitted Remember, we talked about this the other day. Shall, not, can, if. Those are trigger keywords. Shall be permitted where installed as a separate overhead conductor in accordance with 225.6. Okay. All conductors. Let's go to B. Now, well, that was A. Let's go to 303.B. All conductors of the same circuit. All conductors of the same circuit and, where used, the grounded conductor and all the equipment grounding conductors of the bonding conductors shall be contained within the same raceway, conduit body, auxiliary gutter, cable tray, cable bus assembly, trench cable, or cord unless otherwise permitted in 300B 1 through B4. And that's going to be what these are down here. Now, what does that mean? Okay, what is that talking about? That's talking about if you have, for example, a three-phase system, okay, and you're bringing your incoming power coming from your transformer, coming from another panel, your hots, A, B, and C phase, your neutral, and your ground have all got to be in the same conduit. They cannot be separated. You can't have your hots in one conduit and your neutrals and ground to another conduit, specifically because it will cause very bad problems in the electrical system. Okay, let's do this. All conductors of an individual circuit must be grouped in order to reduce inductive heating and to avoid increases in overall circuit impedance. 305, say 305 for similar requirement pertaining to underground installations. That's what you get because you get inductive heating and you have to avoid the impedance. Whenever you start separating these conductors, the harmonic balances get thrown off, and it just starts causing havoc in the electrical system. Now we're going to look at these conductors in parallel and kind of give you kind of an idea. I want you to look at this. This is a really rudimentary drawing, but it's an example of three conduits, okay, with three hots, black, red, blue, a neutral, which is white, and your ground. That is a standard configuration you're going to see in what we're doing. So with this right here, you can see that we have our grounds are all grouped together. Okay, it's equipment grounded conductor. You have your grounded conductor, which is your neutral, and your ungrounded conductors, which is your phases A, B, and C, black, red, and blue. Now notice that this particular one is be three sets of whatever specific wire it is to be able to feed a piece of equipment. A lot of times to be able to get the amperages that we need, for example, if you were building a 1200 amp service, you'd have to have four sets, a set being this right here, four sets of a grouping of conductors, which would be the hot, three hots, neutral, and a ground, okay, going back to your source point to be able to give you your allowable current. So potentially four of these sets will equal 1200 amps. But this is an example of parallel conductors. So connections, taps, or extensions made from parallel conductors shall be connected to all conductors of the paralleled set. Again, what we're looking at is this is one paralleled set of three parallel. Grounded and ungrounded, the parallel set grounded and ungrounded conductors as applicable. Parallel runs and cable trays shall be complied with another 392.20.c. So let's look at the exception on this. Conductors installed in non-metallic raceways ran underground shall be permitted to be arranged as isolated phase, neutral, and grounded conductor installations. The raceways shall be intended to be installed in close proximity, and the isolated phase, neutral, and ground conductor shall comply with 320.b or 300.20b. So basically what this is we're talking about a duct bank, which is a grouping of conduits underground in a concrete encasement. And we'll go on further on that. This is where you're really going to see something like this. Not very often, but this is where you're going to see this. So non-ferrous wiring methods. Okay, that's non-conductors and wiring methods with a non-metallic or other non-magnetic sheath where run in different raceways, auxiliaries, gutters, cables, trade trenches, cables, or cords shall comply with 320.b or 300.20b. Conductors in single conductor type MI cable with non-magnetic sheaths shall comply with 332.31. Conductors of a single conductor type MC with a non-metallic sheath shall comply with 331, 330.31, 330.16, and 300.20b. We could go way deep into this, and we'll get into this later. In the end, every one of these is going to reference back to another point. As long as you remember that you've got a bounce in this book, back and forth, back and forth, back and forth, you'll be able to get through and use this book to be able to find the answers that you're looking for. Okay, we're going to go on down through here a little bit further. Let's look at protection against physical damage. Okay, it's very important that we understand the protection against physical damage. We're subject to physical damage. Conductors, raceways, and cables shall be protected. So let's look at this. We're in a residential stick build, which is wood, 2x4 is your standard house. You have to drill holes in the wood to be able to get from your box up into the ceiling or up from next box down the wall. So this is going to talk about boring holes in both exposed and concealed locations where cable or raceway type wiring method is installed through bored holes in joists, rafters, or wood members. Holes shall be bored so that the edge of the hole is not less than 32 millimeters or an inch and a quarter from the edges of the wood member. Where the distance cannot be maintained, the cable or raceway shall be protected from penetration by screws or nails by a steel plate or bushing, at least a 16-inch or at least 1/16 inch thick and approximate length and width installed to cover the area of the wiring. What does that mean? What does that mean? Okay. Basically, what we're looking at is this right here. We're looking at nail plates. These nail plates are meant and designed to be able to be nailed to the front of a 2x4 or the rafters themselves to be able to protect those conductors going through those holes. Notice that these two, this one's really close. This one kind of gets further back, but this one over here, you can't see it, but this one doesn't have a nail plate because it actually conforms to the inch and a quarter from the front edge of the wood member. Again, we're talking about from the front edge of this wood member itself. Right here is what we're talking about. Okay. Pretty simple. Okay. There's an exception. Steel plates are not required to protect rigid metal conduit, intermediate metal conduit, or IMC, rigid PVC conduit, RTRC, or electrical metallic tubing. Okay. EMT. So you literally could run EMT in those walls and actually not have to worry about the nail plates. A listed and marked steel plate, it's exception 2 here. A listed and marked steel plate less than 1/16 of an inch thick that provides equal or better protection against a nail or screw penetration shall be permitted. And the listed means it's listed with the UL. Okay, that's a trick. They should actually say a UL listed, but whenever they say listed, they're meaning a UL listed fitting. Okay, let's go on. So notches in wood. Does anybody know what a notch in the wood is? Let's kind of talk about notches in the wood. I ask you what they know. If you know what they are, let's take a look here. This is an example of a notch in the wood. Basically, you're just taking a little chunk out of the wood, okay, but not cutting so much of it out of it that you're structurally compromising the wood itself. That's what they're talking about whenever you go back and look at the NFPA link, or pardon me, the notches in wood. So where there is no objection because of weakening the building structure. Okay? In both exposed and concealed locations, cables and raceways shall be permitted to lay in notches in the wood studs, joist rafters, or other wood members where cable or raceway at those points is protected from penetration by nail or screws, by penetration by nails or screws by a steel plate at least a 16-inch thick of appropriate length and width installed over a cover area of the wiring. Steel plates shall be installed before the building finish is applied. Basically, that is before the sheetrock goes on. Okay. You'll see that the steel plates in exception 1 are not required to protect rigid metal, IMC, rigid non-metallic conduit, or EMT. And it goes to talk about the listed and marked steel plate not less than 16 inches thick that provides equal or better protection against the nail and screw penetration shall be permitted. Okay. Non-metallic sheath cables, electrical non-metallic tubing through metal framing. So now we're talking about commercial. Okay. 9 times out of 10, boys and girls, we don't use non-metallic sheath cable, okay, in commercial buildings unless you're using it for temporary lighting, and that's kind of frowned upon nowadays too. Electrical non-metallic tubing, okay, they're going to talk about that here in a minute. That's what we call Smurf tube in the trade. It's flexible, looks like conduit, it's round, okay, it's got ridges inside of it. Like a lot of electricians don't really like it because it's kind of harder to pull wire through. Let's read this. Non-metallic sheath cables and electrical non-metallic tubing through metal framing members. Okay, now what is a metal framing member? Here's an example of a metal framing member right here. Okay, metal stud buildings, commercial buildings, 98% are built with this. This over here is an example of a wood build where you have your non-metallic cable protected, and this one's 1.25 further back. There's just showing your 1.25. Now, mind you, that's talking about that hole right there, the edge of the hole out to the front. Okay. In both exposed and concealed locations where non-metallic sheath cables pass through either factory or field punched cut or drilled slots or holes in metal members, the cable shall be protected by listed bushings or listed grommets covering all the metal edges that securely fasten in the opening prior to the installation of the cable. We're talking about non-metallic sheath tubing or non-metallic sheath cable. Non-metallic sheath cable EMT or electrical non-metallic tubing, where nails and screws are likely to penetrate the non-metallic sheath cable or electrical non-metallic tubing. A steel sleeve, steel plate, or a steel clip not less than 16 inches thick. See, common, they wanted about 16th to be able to keep to use to protect the cable of the tubing. Okay, exception. Listed and marked steel plate other than that's that same exception we've been seeing already. And let's see, we're going to go on to cables and raceways parallel to framing members, and both concealed and locations where cable and raceways type wire methods are installed parallel to framing members, such as joists, rafter studs, or other installed parallel to furring strips. The cable or raceway shall be installed and supported so that the nearest outside surface of the raceway or cable is not less than 1.25 inches from the face of it. Again, we're going back to this right here. Where we have 1.25 inches from wherever that penetration is or the leading edge of that conduit. In this particular example, that's what they're talking about, in this leading edge of where the sheetrock will actually be attached to the face of this and then screwed or nailed. This is an important one, okay? Because years and years ago, we used to be able to get into right directly above, under the metal corrugated roofing deck, okay? Which would mean that we would be able to have a lot of pathing because it was easy to put in. But what would happen is, now mind you, I want to give you an example of what we're talking about under the metal corrugated roof decking. So this is the example of corrugated decking. You see this decking up here, correct? Now, what we would do with this in ours, what we would do is we would take and run conduit in this zone right there. I don't know if you can see that with the color or not. Let's try that. We would run conduit basically above and right through here, okay, in that little zone. What would happen when we do this is that the roofers would come along and they would run screws in all parts of this deck because they lay the decking down, okay? Then there's insulation that goes over the top of it. And then the roofers come in and they put their screws through the insulation down into the decking. Well, they use 6-inch screws sometimes. Sometimes they don't need to whenever they have a thinner insulation. What that would do is that would run a screw right directly into our conduit, okay, which would cause problems, which would cause failures. Let's see. So that's where they said it shall be installed and supported so that it's not less than 1.5 inches measured from the lowest part of the roofing deck to the top of the cable, raceway, or box. The cable, raceway, or box shall not be installed or in concealed locations in metal corrugated shipping sheet deck roof types. Okay. Uh, let's read this informative note. Roof decking materials often repaired or replaced after the initial raceway or cabling a roofing installation and might be penetrated by screws or other mechanical devices designated to provide hold down strength for the weatherproof membrane or the roofing material. That's the screws that I was talking about. We got 2 exceptions. Let's look at these right quick. Rigid metal conduit, intermetal metal conduit with the listed or steel, the malleable iron fittings or boxes shall not be required, okay, to comply with 304E. Rigid metal conduit or IMC with listed steel and malleable iron fittings. So if you're using rigid, you can put that up there, but if you're using EMT, you can't. Exception 2, the 1.5-inch spacing is not required where metal corrugated sheet or roof decking is covered with minimum thickness of 2 inches concrete slab, measured from the top of the corrugated roofing. That specific exception lets you actually, because they use this same corrugated roofing material whenever they're building multi-story buildings. And if you're, as long as you're not on the roof deck, the very top, and if you've got multiple stories, well, once you're below that roof deck, say it's a 5-story building, as long as you're on floors 4, 3, and 2 in their ceilings, respectively, and floor 1 ceiling, you can run that stuff up there, okay, with this exception, which saves you time, effort, and hate and discontent, believe it or not. I want you guys to, can you read through this a little bit? This one talks about cables installed in shallow grooves. This one I want to point out to you. Raceways where raceways contain number 4 AWG or larger insulated conductors, and these conductors enter a cabinet or a box, an enclosure or raceway prior to the installation of the conductors shall be protected in accordance with the following: an identified fitting providing a smoothly rounded insulated surface, a listed metal fitting that has smooth round edges, separation from the fitting of the raceway using identified insulation material that is securely fastened in place, fitted hubs or bosses that are integral to part of a cabinet, enclosure, or raceway that providing a smooth, round, or flattened entry for these conductors. Man, that's a lot of stuff. What does that mean? It's a bushing, a variation of a conduit bushing. Let's look and see what that is. Okay. Here's some examples of some bushings. So this is a plastic bushing that's threaded that you just roll over this connector. This is a bushing for inside of your MC to be able to separate the outer jacket the outer flexible part of a multi metal clad cable, and the connection points. You always use these in MC. Here's a grounding or a grounded bushing, a bushing, grounding bushing with a chair lug on it. There's just an example of a lock nut. There's a bushing that goes just directly on the end of a conduit. And here's another threaded type bushing. Here's some examples here. Okay. These are some terminations. This is where they're talking about any conductor 4 or larger, the bushing is required. Okay. Number 6 and smaller is not required. Okay. In one of these type of termination points, bushing is not required. That is one of those where they're referencing uh, threaded hub or boss that's integral to part of the cabinet. You'll find basically that this one right here on top of your meter bases. Okay. Well, ladies and gentlemen, it's been wonderful today to go kind of a deep dive into this. If there's anything that I can do for you. Now, listen, I'm going to spend a couple of minutes talking about something. Okay. I realize that I'm the instructor. I realize that I am supposed to be the teacher, the leader, and everything else, but I am just an old electrician. I am and have been where you are or you were. I came up from nothing. I didn't have a lot of opportunities when I was growing up. Uh, my upbringing was rough. I was in foster care when I was a kid. I've lived in the projects. I have had to struggle and fight my entire life just to be able to keep my head afloat, just like you do every day. Don't be discouraged in this trade. This trade can change your life. I feel honored that I was able to get into something that I truly love. And like I say, I make jokes about it. I'd say if it weren't for my ex-wife in the Episcopalian church, I would do this for free. It's about the passion that I've developed over the years for this. The passion to be able to continue to learn, the passion to be able to continue to better myself, to better those around me. Um, yeah, yeah. So don't let this online thing too, because listen, guys, I've done online training. Whenever I went to go for my electrical engineering degree, it was online, and it sucked. Self motivation, because that's what this comes down to, is self motivation to get up and listen to that fat guy on the video and answer his silly questions about this little book that we don't really even care about at this point, even though it's the most important book in your life right now other than the Bible, because you're going to be an electrician and this is our electrician's Bible. So don't be afraid. Don't be discouraged. Okay, you can do this. I have full faith in every one of you that you will be journeyed person electricians sooner than you think. Again, this is your Hillbilly Professor. We appreciate you tonight, today, this morning, this evening, and look forward to doing this some more. Thank you very much.